transformations and translations in degrees. In this video, transformations and translations of trigonometric functions will be discussed. Let's start by looking at the equation and then the graph of a trigonometric equation in the form y equals a sine k inside brackets x minus d plus c. The default equation, or the parent equation, is y equals sine x. Transformations, what are they? Transformations refer to any change in the graph where the shape of the graph changes. It can either be a stretch where the graph looks bigger, or a compression where the graph looks smaller. Here is an example of horizontal stretch and compression. This example is vertical stretch and compression. So let's take a closer look. Look at the default key values given the equation y equals a sine k x minus d plus c. A is the amplitude. The default, a is equal to 1. C is the axis of curve, which is the horizontal line cutting the graph into two parts. The default, y is equal to 0. The period, which is the length of one cycle. Now we have a formula here for this. K is equal to 360 degrees divided by the period. The period by default is 360 degrees, so that's going to equal 360 degrees divided by 360 degrees, which is 1. So the default K value is equal to 1. D is the horizontal starting point. The default would be at the coordinate 0, 0. In the real world, nothing ever follows the default settings. There is always ways in which the function can change. Let's review these. There are 4 ways this graph can change. Vertical translation. This means the axis of curve can move up or down depending on the application. Vertical transformation. The amplitude of the applications either stretch or gets bigger or compresses, which makes it smaller, depending on the application. Horizontal translation. This means the x value of the starting point can move left or right. Horizontal transformation. This means the period of the application can either stretch or compression, which will change the period length. As we work through the next part of this video, you may wish to try these transformations and translations in your own graphing software. Geometry Sketchpad. Let's start by looking more closely at vertical translations. This is our default, but now we're going to apply a vertical translation by adding a C value for +3. Then we're going to look at the graph where we apply a vertical translation of -3. How do these graphs change the shape of the image? That's what we need to find out. So let's start with sine x plus 3. You will notice that it has moved up 3 units. The value of C is now 3. The axis of curve is y equals 3. Now, let's look at y equals sine x minus 3. Let's draw in the axis of curve. And we will see, yes, the value of C is now negative 3. And the curve has come down, moved down, translated down to negative 3. So, what are the rules we should follow? If C is greater than 0, the graphs of y equals sine x plus C or y equals cos x plus C are translated upward by C units. But if C is less than 0, the graphs of y equals sine x minus C and y equals cos x minus C are translated downwards by C units. Here's the vertical transformation. Y equals sine x. The value of the amplitude is now 1. Now, let's apply y equals 3 sine x. So 3 now is in the amplitude position, the A position. How does that affect our graph? If we look closely, we will see that the graph has, instead of ending at 1, it now ends at 3. So we can say that it has stretched up by a factor of 3. And of course, if the amplitude goes up to change the maximum point, the amplitude is also going to go down to change the minimum point. This represents a vertical transformation by a factor of 3. Now, let's take a look at y is 1/3 sine x. And what happens, it's shown in the turquoise color. The A is now 1/3, so the distance is only 1/3 the length, so it would go up 1/3. So the amplitude is 1/3. We can say this represents a vertical transformation by a factor of 1/3. The rules to follow: if A is greater than 1, the graphs of y equals A sine x or y equals A cos x are stretched vertically by a factor of A. The amplitude of each function is A. The second scenario, if 0 is less than A, which is less than 1, the graphs of y equals A sine x and y equals A cos x are compressed vertically by a factor of A. Compressed, of course, means get smaller, stretch gets bigger. The amplitude of each factor is A. Horizontal transformations. Analysis, y equals sine x. What are the default settings? The value of k is 1. The period length then is 360 degrees, shown in our diagram. Y equals sine 2x. Let's see what this will do to our graph. So what's happened is shown in the green color, and we can see that it has compressed. Where before we had 1 period, now we have 2 periods. The value of k is 2. That gives us the 2 periods. The period we want to calculate now, 360 degrees divided by k, which is 360 degrees divided by 2, which is equal to 180 degrees. And if we look closely, Yes, the period length is 180 degrees. What does this tell us? That this is a horizontal compression by a factor of 1/2. We use the factor 1/2 because the graph's length is now 1/2 of the original. Be careful with this. Now, let's try 1/2. Y equals sine 1/2 x. So the value of k is 1/2. The period is 720. So if we look at our graph shown in the orange, we can see now where before it had 1 period in the default setting, now we have 1/2. So it takes twice as many lengths to get 1 period. So we say that this is a horizontal stretch by a factor of 2. Note, if it's 1/2 in the equation, it's 2 in the answer. Rules to follow. The formula, period equals 360 degrees divided by k. If k is greater than 1, the graphs y equals sine kx and y equals cos x are compressed horizontally by a factor of 1 over k. If 0 is less than k, which is less than 1, the graphs of y equals sine kx and y equals cos kx are stretched horizontally by a factor of k. Now, let's look at horizontal translations. The analysis, y equals sine x, the default graph. Here, the value of d is 0. This means that the x value of the starting point is also 0. Now, let's add. Notice it goes inside the brackets. Y equals sine x minus 45 degrees will be our example. We will note on our graph that it has shifted over by the value of d 45 degrees. The direction is to the right. So if the bracket is x minus 45, that would be plus 45 as the direction. The value of the starting point is 45. The horizontal translation has been to the right 45 degrees. Now, let's look at the example y equals sine x plus 45 degrees, shown in the graph as the magenta color. The value of d is 45 degrees. The direction is to the left. The x value of the starting point then would be 45 degrees. The horizontal translation has been to the left 45 degrees. Rules to follow. If d is greater than 0, the graphs of y equals sine x minus d, y equals cos x minus d are translated d units to the right. If d is less than 0, the graph of y equals sine x plus d and y equals cos x plus d are translated d units to the left. Now it's time to practice these concepts.